there are two kinds of values that we have. One of them is continuous and another one is categorical. Categorical values are basically the thing about them is that they have discrete values. They cannot have continuous values like 1.02, 1.03, 1.04. They can only have one of the discrete values like 1, 2, 3, 4. Like they can take values in a finite set. So for the computer cannot, let's say if I give you a column as in this example of gender, right? You have male and female. So the computer cannot interpret male and female as a number, right? So what we have to do is we have to convert those categorical features into some numbers so that computer can process it. So let's start with this notebook. I've shared the files with you. If you want, you can follow along. I'll upload the files. ये तीन files मैंने तुम्हें chat पे भेजी by the way. Adults, Mercedes Benz and Titanic. Right. So पहले let's talk about the Titanic data set. We have this column and data set. It has only two values, male and female, and obviously these are discrete values, right? So how do we convert these values into numbers? We have a simple function in pandas which is get dummies, right? Get dummies just finds out the total number of discrete values in that column and encodes those categorical features using those values. So in this case, if we use pandas.getDummies and run this cell, you see that male has been replaced by 1 and female has been replaced by 0, right? If we had, let's say, a third value, male, female, and transgender, then we would have 0, 1, and 2. That is how get dummies works. Now there is another column in this Titan dataset which is embarked, which basically means which, I think it means which class they boarded the boat on. It is actual Titan dataset, right? I expect you guys to know what Titan dataset is. So it has three kind of discrete values: S, C, and Q, and fourth is NaN, which is basically the missing values. We will use the drop now function from pandas to drop those missing values. Now, if you run the same cell, you will only find three kinds of values, which is S, C, and Q, right? And if we perform pd.get dummies into it, we get two kinds of values, which is embarked Q and embarked S, right? So I guess you guys know how get dummies works. Any doubts until now, if any? I have any doubt. Right, let's proceed further. So this is just another example of the same thing. This is another data set, Mercedes Benz.csv. Uh, let's see. The columns that we have basically x0, x1, x2, x3, x4, x5, x6. And if we see the number of unique or basically the discrete values that each column has, we see that x0 has 47 unique values, x1 has 27, and so on. So these are the number of categories in each column, right? You can also count the value counts of each category in each one. Let's say we have the column x1, right? And we want to find what is the, let's say, value count of each kind of discrete value. So x1 has these kinds of discrete values, S, B, L, V, R, and these are the number of samples corresponding to those unique categories. right? So you guys understand what this cell means, right? If you have any doubt, please raise your hand. Okay, let's proceed. So this cell basically tells you top 10 those categories which have the highest number of value counts, which we can observe directly from this AASBLVRIACO. These are the categories in the column X1 that have the highest number of samples in them with them. Yeah, I guess that was the categorical encoding part, right? You guys have any doubts with categorical encoding? Or you, if you want me to explain it again? All right. So let's talk about second kind of encoding, which is ordinal number encoding. All right. So that we saw there are two kinds of categorical variable, right? One of them are simple categorical variables, and other are ordinal variables, right? And the thing about ordinal variables is that they have a certain order associated with them. If I had to give an example, it would be if I said okay, we have a column corresponding to the educational qualification of someone, right? So educational qualifications could be, let's say, uh, someone must have studied until high school. Someone must have completed, let's say, plus two. Someone must have graduated. Someone must have completed post graduation as well. Right. So you see, all of these are categorical variables because they have discrete values, right? A person can either be can must have studied from high school, or they must have been graduated, or they must have post graduated, right? But the point here is that these are not simple categorical variables, right? They have certain order associated with them, which means that post graduation, although it is completely different from graduated, it is somewhat greater than graduated. Graduated is greater than plus two, and plus two is greater than high school, right? They have an order with them. This is why they are called ordinal categorical variables. They have certain order with them. And another example is basically date time, right? One date is completely different from another, so it's basically a categorical variable, right? If I say today's date is 28, and yesterday's date was 25th February. So these are discrete values, right? So they have to be categorical variables, but they have an order associated with them. That is, which means 26th Feb came after 25th Feb. So there's an order between them. So date is also an ordinal variable. See how we can process date time in Python. I guess you guys know date time library. Date time library is used to process dates in Python. And if I run these two cells, I'll get today's date with the exact timestamp, right? 2023, February 26th, 11, 8, 49, 7, 7, 3, 2, 6, 2. This is exact timestamp, right, of current time. Now, if I want to subtract 3 days from this current date, right, what I will do is today's date minus date time dot time delta open bracket 3. So what I will get is exact time step, but 3 days back, which is 23rd February. See, we have created a list of dates. This is basically the dates in past, I guess. This is from 12th February to 26th February, right? This is a list of dates. Extract only the day part of it, right? See the day part, we have these dates from 26th to 22nd. Now we know that basically each day has a certain weekday associated with it, right? Like today is Sunday, yesterday was Saturday, and so on, right? So we can also extract that information out in the date. You can see I had 26th February 2023, and the weekday was Sunday. We can use the datetime library easily. You have to do is you have to pass dt.day name, and it gives you the weekday. So these weekdays are basically categorical variables, right? Because they have discrete values. Monday, Saturday, Friday, Thursday, Wednesday, so on. Now to convert those values to numbers, what we will do is we will assign each of those days with a number. Let's say we assign Monday to 1, Tuesday to 2, Wednesday to 3, Thursday to 4, and so on, right? We create this dictionary and we map that dictionary to our data. Now if you observe, each weekdays is associated with a unique number, right? And also you should note that those numbers have an order with them, right? Sunday is greater than Saturday, and Saturday is greater than Friday, which is greater than Thursday. Those numbers have been assigned purposefully to those weekdays that come in those come in that order particularly, right? Like Sunday comes after Saturday, so we have to assign Sunday a greater value than the value assigned to Saturday. This is one way of processing ordinal variables so that the computer can interpret them. Now, the third kind of encoding is count or frequency encoding. This kind of encoding is basically used the to make the results of our model somewhat better, right? Let's say we use this data set adults.csv. I've uh, given to you this data set on chat. Right. So if you observe this train set, yeah, this is the data set. We have employment, degree, status, designation, family, job, race, sex, and country, right? This is basically related to the adults, right? Where they're employed, what is their degree, their relationship status, their designation, family, job, their race, their sex, and their country. So now all of these are basically discrete or categorical variables, right? Employment, degree, status, designation, all of them have discrete values. Now what we're going to do is we're going to see how you have it out. Shiva Ramakrishna Reddy. You have it out. If anybody has a doubt, they can raise their hand right now. Okay. Uh, so this basically tells how many unique labels we have, right? For employment, we have 9 labels. For degree, we have 16 labels. We can also observe these labels, right? If I have the train set, I have the employment column, and I want to see how many labels it has. Yeah. So these are the 9 labels that I have: state government, self-employment, private government, self-employed, without pay, never worked. Right? These are the 9 labels that we have in the employment. We can do so for degree as well. These are the discrete values that those columns can take. These are the 16 labels that we have for the degree column: bachelor's, HS grad 11th, master's 9th, some college, 12th, preschool, etc. Now we also have the column for country, right? Let's say I run the column for country. These are the total number of countries that we have in the country column: United States, Cuba, Jamaica, India, etc. Right? So all of these are basically discrete values. So these are categories. So the country column is a categorical variable, and if we want to process this variable, what we're going to do is we're going to convert these values into numbers. And for that, what we can do is we can count the number of times, let's say United States, right? We're going to count the number of times United States has been repeated in our data set, which means the number of samples that have their country as United States, and replace all those columns with that value. So 29,170 samples have United States as their country. 643 samples have Mexico as their country, right? So let's run the next cell to see what we're exactly going to do. What we are doing is, let's say key some sample has their country as United States, right? So for that sample, we will replace the country with 29170, which is the number of times United States was repeated in our data set in the country column. So our hypothesis is basically that our model will basically learn some kind of relationship between the number of samples with that particular label and correlate them with the variable that we want to predict. So do you guys have any doubt with this? You can still raise your hands if you have doubt with anything that I showed you. Yeah, so we have advantages and disadvantages of this kind of encoding. It's basically easy to use. Obviously, the code is very easy, but it does not increase the feature space. It means if we had one column, we're just going to replace that column with, let's say, strings with numbers, right? It's not going to give us some extra information. Disadvantages is disadvantages. It will provide same weight if the frequencies are same. This is obvious. If let's say some country was repeated the same number of times, let's say France and Greece, right? The model will not know the difference between France and Greece. It will treat both of those countries in the same way, right? That is one of the major disadvantages of this kind of encoding. Let's study another kind of encoding for ordinal variables, which is target guided encoding, right? Which basically means, let's say that I have some column and I have the target column which I want to predict. What I'm going to do is, if I have some label in my column, I will count the number of times that label has come in relation with the target. And I will replace that label with a joint probability of being 1 or 0 according to the target. Let us see what that basically means. We'll use a Titanic dataset. It has two columns, which is survived and cave in. Survived is basically the column that we want to predict, right? We want to predict whether a person survived the disaster or not, right? Given the variables. So what the variable that we have is cave in. It's replace the missing values with missing. And we're going to just take the first value out of their cabin, which means if they were in some cabin that starts with C, we're going to replace that cabin with C. If the cabin value was missing, we'll replace that with M, and so on. So now we have a proper ordinal variable, which is cabin, with some discrete values, which are M, G, C, E, etc. These are the unique values that we have for the k-bit column. And it's an ordinal variable, right? They have an order between them. Some k-bins were better than others, right? Now what we're going to do is we're going to calculate, let's say for k-bin A, what was the percentage of people that survived? So people who boarded the cabin A survived 46% of the times. I could say 46% of those people survived the disaster. And the people who boarded the cabin B, out of those 74% people survived. So obviously cabin B is better than cabin A, right? Or let's say a ticket for cabin A, cabin B must have been more expensive than the ticket for cabin A. This is the information that our model is going to extract from this map that we have created. Well, now we are going to just replace the labels that we have in that ordinal variable with the probability of surviving, which basically means what percentage of those people survived. Mhm. Yeah, this is where we're going to do it. Yeah, so now we have mean ordinal encode column, which says if their cabin was M, what was the probability that they survived, which is 0.29, 0.029, 0.29. And if their cabin was C, what was the probability that they survived? It was 0.593220. So that was how mean encoding works. If you guys have any doubts, you can ask right now. You can raise your hands or just put your doubt in the chat box.
How do you decide which type of encoding to use for a particular data set and all?
Yeah, that's actually a good question. What you have to do is it depends on what kind of column you have, right? Let's say if you have a categorical column, you're just going to do simple number encoding that we did, or one hot encoding that we did in the beginning, right? This kind of encoding if you have a simple categorical column, right? Because male and female don't have an order between them. But if you have an ordinal column, let's say dates or cabins or weekdays, then you're going to use a different kind of encoding for them. You're getting my point, right? Then you're going to use ordinal encoding. Hello.
Yeah, I get it.
Yeah, and if you're talking about these kinds of encoding, whether we want to use counter frequency encoding or we want to use let's say mean encoding, if you want to decide between those, I would suggest that you would have to try each one of them and see for which one the model performs the best. It's a trial and error game.
Okay, okay.
Any other doubts? If you guys don't have any doubts, we're going to move on to the next part of the workshop. Sumed, uh, ready enough?
Yeah, yeah. Uh-huh.
Let's stop sharing.
Yeah. हाँ वैभव मुझे वो ऑर्गेनाइजर वो शेयरिंग एक्सेस दे दो.
हाँ.
Right. So now we'll be dealing with missing values. Like until now we dealt with how to deal with encoding variables and all of those stuff. Now we'll deal with missing values. This actually represents a huge problem that we usually face irrespective of what context, what category of context you are given. In data science, dealing with missing values almost decides a large part of how you'd go ahead with the problem statement. Right. So coming to the main issue, why are missing values even present, right? So if we talk about a real-time data set that is actually useful and it's gathered by some server or something, most of the times people may hesitate to put down information. Okay, just a second. People may, right. People may hesitate to put down the information. Next, reason. Next, coming complete information may not be available. This is the reason most of the times, like the accurate information that is to be put into the column is not actually available. And next would be human errors. So instead of typing something, it would have been left blank. So listing the reasons. Now we'll move ahead. What are the different types of data that may be missing? This is actually important. Obviously we have either numerical data that is missing, that is continuous or discrete, or a categorical data that is missing. Now the main point that comes is the like the variable set that is missing, is it actually missing completely at random, that is like we have no relation between them, just like randomly it is missing, then it is called as missing completely at random, which means there's absolutely no relation between the data that is missing and other values that are present, right? Now this is a very difficult case. Now we do, like there is a lot of data, let us say there's some data missing and we don't know what it's to be filled with actually, because it's missing completely at random, there's no relation, right? It becomes difficult to figure out. But most of the times what happens is we can find some relation at least between the missing variables and the non-missing variables, and in that case we'll call it as missing data not at random, right? There are some systematic missing values that are actually most of the times if you're giving a contest or any of those things, on purpose a few data points are removed just so that there's some more work on your side to understand the analogy and the correlation between the non-missing ones and the missing ones, and then develop a relation to fill the missing values, right? So there is some relation between the missing and the non-missing values in this case. Right. Now moving ahead, just to show some examples of how things work, what exactly we need to do, I'll start to run the cells. Right. For now, we'll understand the main thing that occurs when something is missing. Usually what a missing object is, dealt with, what is the data type? It's either none or it is NaN. We'll see this later. So currently, let us say I create an array where the first element is 1, the second is none, 3 and 4, right? Now, if I try to type this, like if I try to get the output, it would say data type is object and it is showing like, see, like these three are integers and this one is none. So the net the data type becomes an object. We'll see more on this later, like when we have a an array of a string and one of the objects is one of the element of the string is kept as none, what will happen when there is an integer array, and then when we put one of them as none, what will happen? We'll see all of these later. Now the main point comes, let us say you didn't know what vals contained, right, for now, and you're given some random data set and you try to just for some info, for some gaining some information, you say you want to type vals1.sum, right? Once you type this, you will immediately be facing an error that says unsupported operand type plus of between int and none type. That is, we can't perform an addition between an int and a none type object. So now this is clear. This is what causes the main issue, right? So once this is clear, like we're now understanding why none type object causes the whole issue that is, it is trying to do. Next, when there's a missing value, there's another way of representing it. When there's a numerical missing value, we usually represent it as NaN, right? Most of the times, the simple abbreviation is not a number, right? NaN's abbreviation is not a number, right? Next, coming, it is a special floating point value recognized by all systems that use, right? Now the main point that comes here is, now you can see the difference. Let us say instead of putting none, I've put np.nan over here, and this is declared as an NP array. And once I check the data type, it automatically shows float. I'll run this cell and I'll show it to you. Right. Instead of showing, like, see, instead of showing an object data type, it is now showing a float data type. Right. Now, why this is happening? Instead of placing a none, I have placed NaN, and NaN is recognized by even NumPy. This is NumPy. NaN is recognized by NumPy, and it's a simple, notation saying that I don't know what the value here is, and I'll simply say it is not a number currently, NaN. So the data type automatically becomes float. We'll see this. I'll just show it to you actually, the conversion of what exactly happens. Right now, let us say I have a floating point integer. There's a floating point array, and when I put np.nan in it, like if I put one missing value in it or many missing values, while storing it, there is no change. It is still stored as a floating point array only. Next, coming to object, we have an array of the type object, and in that, if I put an empty if I put a nan value, it would, while storing it, it would still be no change. It would still be stored as an object. Now, let us say I have an integer array. Now, if I put a nan value in it, I'll show you an example over here. Like let us say let us run this and see what happens. It was float 64, right? You're understanding. I've stored an integer array, and one value I've made at np.nan, and like I've put a none value. And now if I check the data type, it becomes float 64. That is automatically, while storing, it didn't store it as an integer, but it stored as a float 64. Now let us say I have a boolean array. Let us say I just made this true, false, true, and let us say what this, like actually it had to, like if you think logically, this array had to be stored as a boolean array, but now if I check, and right now once I put none here, it is stored, the data type becomes an object data type. That's like we're seeing right over here. So this is a simple conversion table that happens. It's not of much importance, but just for information of how exactly the storing occurs, we just try to see this. Now coming back to the place where we were, now let's understand if there is a none value, what will happen, right? Like let us say, right now notice that NumPy chose a native floating point for this integer. This means that unlike the object array from before, this array supports fast operations pushed into compiled code. You should be aware that nan is a bit like a virus. Like the main point is, let us say we have a nan in an array, only one single missing value in an array of size 100. Now, if I try to do any operation on that array, you can't perform sum, you can't perform mean, you can't perform any arithmetic or mathematical operation because one of them is treated as a none value. Now, let us see what happens if I do 1 plus np.nan. This also becomes nan. Any mathematical operation performed with nan becomes nan, hence it acts like a virus, like it infects anything that's attached to it, right? So these are the basic operations that will happen. Now we are understanding what is the main problem with with none values. Like let us say this was vals2, right? I just run this. This is vals. If I try to find the maximum, sum, minimum, sum, anything, it will be nan. So like let us say you're dealing with some column that you don't know, you can't see all the values of column of a data type of a data frame. Now just you wanted to check the mean, and once you type this, if you get nan, you must immediately understand that there are some missing values in your data frame or in that column, and now you have to deal with it, right? And just to get back, like am I audible and is everything clear until now? Like you're understanding what exactly nan is, why is it causing such a big issue, and why are we even creating one big slide about it, right? If you have any doubts until now, understanding what is nan, what is none value, why is it coming, you can ask immediately. You can raise your hand, no issues, or you can put it in the chat. Right, assuming that there are no doubts, I'll move ahead. Now what happens if you see here is, there is, if you have stored, if you have put your missing value as nan, np.nan, now NumPy by itself provides a special feature which says np.nansum, which means ignore all the nan values and whatever else is present, please give me the sum of that, right? This is provided by the NumPy library, right? And this happens only when you put it as np.nan, right? You're understanding this? So let us say there are some missing values in your data frame or in your column, and you say, okay, leave those missing values, at least tell me the sum of the remaining numbers. If you want to do this, you can run these commands: np.nansum or np.nanmin, nanmax, all of the other nanmean, everything, all of the other mathematical operations would work. So this is provided by the NumPy library. So understanding that there is some advantage of using the NumPy library when we have NaN values, right? Coming to the next thing, we'll deal with what happens when NaN values occur in a pandas data frame, right? NaN and NaN both have their places, and pandas is built to handle the two of them nearly interchangeably, converting between them. So what happens is pandas can work in such a way that it can deal with NaN and NaN, and it almost assumes that they both are same and works in such a way. I'm just running this to see what happens, right? So while it's storing, it is obviously storing this as a float, as I've already mentioned. And once you just take the output, it shows that the second object is NaN and the fourth object is NaN. Nothing really great over here, just to understand how things are occurring, right? Pandas automatically typecast when NA values are present. For example, if we set a value in an integer array to np.na, it will automatically upcast the floating integer to accommodate the NA value, right? Nothing great. You can say this like this, just creating a panda series of range 2 matlab, it'll be like until 2 all the values from 0, so 0 and 1, right? Now I've created a pandas data series, that is a column, and I've made sure that the data type that is mentioned is X, right? Now if I do something like I say X of 0 is equal to np.nan, now if I check the data type, it will automatically become float. This is again restating the previous point, that irrespective of pandas or numpy, irrespective of what the storing this thing is, mode is, when we convert, when we when we store it as an integer, and in that integer array or in the integer series, if I put a NaN value, automatically while storing it upcast the whole series or array into a float array instead of a this array, instead of an integer array. Now seeing what happens when we have strings, like let us say I'll remove this np.nan temporarily. Let us say I had this series of strings, right? If I put an np.nan, it automatically stores it as an object. It was also storing it. It was storing it as an object even before this. We need to understand that string is treated as an object variable in the object data type in the pandas and Python type. Coming to the next, we saw this already, that if I put none type in an array, it will automatically store it as an object. Nothing great over here. I've already dealt with this. Right. Now we saw what are NaN values, why are they occurring, what is the difference between NaN and NaN. We understood that most of the times in NumPy and Python, NaN and NaN are dealt interchangeably. Now learning about all of these things, let's come to the main thing. How do we deal with them, and how do we operate on these NaN values, right? Now coming to pandas, they treat NaN and NaN as essentially interchangeably, right? And they are used for indicating missing values. To facilitate this convention, there are use of several useful methods for detecting, removing, and replacing values. First, let us come to the detection method. If I want to detect that in a pandas data frame or in a pandas series, is there a null value? Well, how can I do it? The method is null. Let us say I created a data frame or created a series first, a pandas series. Now, if I simply do dot is null, if I use the is null method, it creates a mask. It will return a series where if the value is missing, it will say it's true. If the value is not missing, if it's present, it will say it's false. You can clearly see the output. The first element of the series was not a missing value, it was a present value, hence it said false. The second one is a missing value, hence it said true. The third one is not a missing value, hence it said false. The fourth one is a missing value, hence it said true. Like this is pretty much clear, right? No doubts here. Now, just like is null, we have the exact opposite method that is called as not null. Pretty much makes sense, it's like common sense. So not null would do the exact opposite. It would create a mask where if your value is present, it will say true. But if it's absent, it will say false, right? Now this is like data of data dot not null. That is, show me only those elements of data which are not null. Clearly it says at index 0 we have 1 which is not a null, and at index 2 we have hello which is not null, rest all are null. So this is a simple method of understanding which elements in an array or a series or a data frame are present, are null, or which of them are not null, right? A simple bit mask that can do this, a Boolean mask, right? These null and not null methods produce similar result to Boolean results on data frame also. Like we did this on series, we can get the same result on a data frame. Any pandas data frame or whatever it is, storage thing, we can get the thing. Dropping the now we saw how do we detect the null values, and how do we say where a null value is present. Now let us deal with the method of dropping them. Like let us say your data was a PD series. We saw that the second and the fourth variables were none, right? The second and the fourth elements were none. Now a simple command called dot drop na, that is drop na method, simply drops and deletes every single element that is a missing value. Once I do this, we can clearly say that the data has only two elements, 0, that is at this first element we have 1, second element we have hello, right? Now if I do this, data equal to data dot drop in, and now if I print data, we can clearly see that the other elements got removed and we have only 1 and hello, right? For a data frame, there are more options. Consider the following data frame. Let us say this is the data frame that I've created, and I'll print the data frame. Right now, if you analyze the problem, a single row has 3 columns associated with this, right? So this is a 3 cross 3, data frame. Now, if I have to understand how does drop na work in this, until now we were dealing with a series. That's a one-dimensional thing. Now this becomes a two-dimensional matrix or a data frame. Now, how do I deal with drop na? Right. So the default drop na works in such a way that it goes to every row and checks all the columns. If any of the column value of a row is a nan, it will remove the whole row. Like let us say in this row, the second column value is none, so it will remove the whole row itself. Coming to this row, if I check, none of the values are missing, so only this row is kept intact. If I come to the third row, again at least one of them is missing, so it will remove. So what drop na does in a data frame is that if any row has any missing value, not all, if it has even a single missing value, it will delete it, and only those rows are kept which have all present values in each of those columns, right? We can clearly see that this is the result. Only the first row is kept intact and all the other rows are deleted, right? Now this becomes a bit troublesome, right? Like what I wanted to see is we are losing so much of data here. We had 3 points, and just because one value is missing, we deleted the whole row. That is, we lost the information of the whole row. Now this becomes a bit of a problem. Now we'll see later that how do we deal with this problem, right? Now just how we did with the columns, just how we did with the row, we can do it with the columns as well. Like I'll check each column, and even if a single value is missing in a column, I'll delete the whole column, right? Like this column would be deleted because this is none. This column would be deleted because this is none. Only this column would be left, right? As you can clearly see. Now I can do drop na, but in the axis, that is a parameter of the drop na function, I'll just say columns. Instead of doing it for the rows, do the exact same thing for the columns, right? You can see the results. Now what we'll do is we'll see variations of the drop na function. Now let us see this thing. Now I do df of 3 is equal to np.nan, that is set the whole third column to nan, right? Set the whole third column to nan. Now it is set. Now in the drop na, what I'll see is there's a variable, there's a parameter called how, right? I'll say axis is columns, and in how I'll say all. What does this mean? I'll say delete only those columns which have all variables as none, right? And as you can see, this column is kept intact because not all of the values in this column are nan, but in this column all values were nan, so it deleted the whole column. So now we can see some upgrade, at least. Like we can specify the threshold as to at what number of nans would you delete, right? Now coming to the next thing, again this is the most important variant of the drop na method. We can specify a threshold. What we say is, for finer grained control, the thresh parameter allows you to specify minimum number of non-values that have to be kept. See, currently this is our data frame. Now what I'll say is drop all those rows. Like let us say this drop na. What does thresh mean? Thresh defines the minimum number of non-missing values, that is present values, that I need to have so that I'll keep the row. Like let us say axis is rows. This row has 2 missing values. This row has only 1 missing value, and this row has 2 missing values. If I make the thresh has 1, but at least if there is one present value, keep them. You can clearly see that all rows are kept because every row has at least single one value. Like here 2 values are present which are not missing. Here 3 values are present which are not missing. Here 2 values are present which are not missing. Now if I increase the threshold to 2, we can still see that everything is intact. But now if I make the threshold as 3, now we see that the first and the last row are deleted because they had only 2 present values, whereas the second row had at least 3 present values, right? So we can use thresh to just alter thresh values and understand. Most of the times what happens, like let us say there are 4 columns and we want to drop only those which have all the 4 columns as NaN, or at least which have 75% of the present values, right? We can change so on and so forth. You can understand the logic behind this, right? So any doubt until now of using is null, not null, drop NA? Any doubts on these 3 methods and usage of these 3 methods? You can raise your hands or put it in the chat. I'm waiting for 30-40 seconds if you have any doubts. Right. Again, I'll assume no doubts and I'll move ahead. Now we've understood how to deal with them, at least, like how to deal with these missing values. Is null, not null, and drop any, right? Now let us deal with the most important thing. How do you fill these null values, right? Now we dealt with detection and dropping. Let us see with filling them. This becomes the most important task. Sometimes rather than dropping an NA value, you'd rather replace them with a valid value. This sounds really logical because if you simply drop them, you'll be losing a lot of data. This value might be a single number like a 0, or it may be a sort of imputation or interpolation from good values. You could do this in place using is null method as a mask, but because it is such a common operation, pandas provides fill NA method, which returns a copy of the array, right? So now what they are trying to say here is pandas by itself has a method called as fill NA, which, as the name suggests, fills the null values. Now in this fill NA, you can give a lot of parameters. Now first let us understand slowly, moving ahead. Let us say this is our data, right? So I've kept the second, third, fourth, and fifth, all the elements as none. Now moving ahead, in the fill NA function, if I give a single parameter as a number, it will automatically fill all the missing values with that number. As you can see, it filled all the missing values, all the 4 missing values with 0, right? This sounds a bit illogical, but it is at least some improvement other than deleting, right? If you delete, you simply lose the data. So filling 0 rather than deleting is a bit better, but we can clearly see later that we can get even better methods, right? Now coming to the next method, which is a bit better than just filling a random value. This is called as ffill, which means forward fill. So what we do is we'll start with the first element and we'll slowly move ahead. If I find a none, what I will do is I'll replace it with the previous method, previous value, right? Now, as you can observe, like this was nan. What I'll do, as soon as I encounter a nan, I'll go to the previous guy and I'll check. Okay, this has 1, so I'll fill this with 1. Next, I'll go to C. I see C is also nan. Now I'll go to B. B, if you have to understand now that B is already filled with 1. B is filled with 1, then only I've entered C. I entered C, I see, okay, C is also nan. Now I'll fill C with B, which is 1. So it propagates like this. And once I do this, you'll understand automatically all of them get filled with 1, right? And the data type becomes float, obviously, right? So ffill, that is forward fill, is another method. Now obviously if the forward fill exists, even a backward fill would exist. That's common sense. So we would do the exact opposite. We would start from the last person, the last element, and we would keep moving back. And once I encounter a nan value, I'll go and check it with the next element, right? Not the previous element. I'll go to the next element and I'll check if any value was present in the next element. I'll fill it. If the next element was also nan, then I'll do no change. Now you can see that even when I do backfill, there is no change because we start from E. We start from this guy. We'll see. Okay, this is nan. I can't do anything. I'll move to D. D is nan. Now I'll check. Does at least E have some value? E doesn't have a value. D remains nan. We go to C. We'll see that C has a nan value. Now we'll check with D. Does D have any value? No, nan. As like this propagates in this way, and backfill and forward fill are also understood, right? So in this case, backfill had no advantage because the last element was nan. Right, we couldn't propagate further. Like continuously from the last element, everything was none. So we found no advantage of backfill, but there was a pretty much good advantage of forward fill. Right. Moving to the next one. Right. Now, what we can do, like until now we were dealing with columns, we can all like fill NA when it comes to a data frame. You can specify the axis. Like you want to perform the forward fill on a row or on a column, right? Now let us say I said axis equal to 0, which means I'll perform on the row and I'll perform forward fill, right? Just 1 second. Right, we can see here that the first value remains none because there's no value behind it, since we are doing forward fill, and all of them remain none because we are not doing anything over here. Like we can see that the fill NA works similarly even on a data frame. That was the conclusion of this, right? Now we'll work with a real data set. Like this is a Titanic data set. I've downloaded it and I put it on my drive, so I'll extract and try to deal with it. Right, just revising a few techniques. All the techniques of dealing with or handling with missing values, one of them is the deleting of rows, which makes like with this you can consider this to be the least effort method, obviously. Next would be mean, median, mode replacement. That is, wherever I find the missing value in a column, I will go to that column and I'll get the mean of the present values, or the median of the present values, or the mode of the present values, and I'll replace all the missing values with the mean, median, or mode, whatever of your choice. Next, assigning a unique category or creating a new column feature. We'll see this later in detail. Like this, a better explanation will be provided once we are dealing with examples. Next is predicting the missing values. Now we'll use some more algorithms or methods like linear regression or any other of those classic ML algorithms to find the missing values. Next is using other algorithms like KNN, all of these methods to find which support missing values. Right now, this is the brief of what we'll be doing next. Obviously, the first method we see with deleting rows. So what we do, like we have loaded the data frame. If you just want to see how the data frame looks like, this is how it would look like. The obviously would be familiar with the Titanic dataset, passenger ID, survived, P class, namesakes, all of those things, right? Now coming to the length, obviously we have 891 rows. Now what I do is I'll check df.isnl.sum divided by length of ds into, now what we are checking is for each column, what is the percentage of missing values. In passenger ID, we have no missing values. In survive, we have no missing values, so on and so forth. In the highest missing values is present in the cabin row, cabin column, right? We can see 77% of the values are missing. Now this becomes a huge problem when 77% of the values are missing. Now we see how to deal with this, right? One simple method is we can do df.drop. Let us call this as cabin. Simple method is just drop the cabin because there are 77% of missing values. Now this is a huge number. We can consider dropping because more than 3/4 of the data is missing. So simply just df.drop cabin, access is equal to 1. Now if you want to, obviously you would have learned this. If I want to store it as a change, I can do df is equal to df.drop, or here I can do in place is equal to true. Either of them, I can do either of them to make sure that this changes stored in the database, right? So it's stored in the data frame. Now moving ahead, dropping was one simple solution, not a complex one, but it's not always the best case. No, it's not always the best solution, right? Let us see what are the pros of this method. Complete removal of row with missing values may result in a robust and a high accurate model. What this is saying is, let us say if a row with has 70, it may increase the accuracy. It will increase the accuracy, right? Deleting a particular row or column with no specific information is better since it does not have a higher weightage. So what, again, the same point is being repeated, that it would simply confuse the model, and would anyways, even if we are including it, it would have no higher weightage. So it's better that we delete it. What are the cons? We lose a lot of information or data, right, while deleting something. Now, works poorly if the percentage data of missing values is high when compared to the whole data set. Now let us say I have in a data frame, I have 70% of the rows which have at least one missing value. Now, if I go on deleting it, I'll simply lose 70% of the data set in one go, right? It works poorly when the missing values is high percentage when compared to the whole data set. We can understand this, right? So hence, we have to discover another method such that we cannot simply delete, right? Moving ahead, mean, median, mode imputation. what we do here, I'll explain going ahead. Right, df.decennial.mean. What we did here is we used only these columns, age, fair, and survived. We ignored the other columns. Right, now we can see that in survive there is 0%, in age there is 20%, and in fair there is 0% of missing values. Right, now we create a function called as, like, we just write one line that is called as impute nan, and it takes a data frame, a variable, and a median as the input. Right, what we do is we create a new column in the data frame where we have filled in the missing values with the median of the present values. Right, as you can clearly see, we create a new column, and what would be the value of that column? It would be the fill na of medium. That is, we fill the missing values with the medium and we store it in the new data frame, right, as in the new column. Right, now first what I'll do, let us say age has the highest missing percentage, it has 20%. So I'll compute the mean of the median of the age. It turns out the median of the age is 28. Once I've computed the median, I'll run the impute nan function. We can see that after running the impute, like, let us say once I'll show it to you. Before this, what was it, and after this, what is it, just to get the changes. Right, before this, as you can see, age has some missing values, nan, and all of those things, as you can see over here. Once I've imputed nan and I've done df of age, we see that age by itself, like age by itself may contain nan values, that's still present, but we created a new column called as age median, which was not present in the previous one. As you can see, it's not present. We created a new column called age median, and we have imputed all the missing values with the median of the present values. As you can understand, this is a much better method, that because we are not losing data, and imputing by the median sounds a bit logical, at least. Like if let's say there's a missing value, it would sound logical that at least put some median or mean, it would make sense. At least we can normalize the data by doing that. Then we can get a better distribution. Right, now we'll see the main thing, that before imputation, what was our distribution of data, and after imputation, what is the distribution of the data. See, before the imputation, that is the age column, has a distribution that looks like this, right, which is not very similar to the normal distribution. Once we use the age median and we have made our own imputation, our distribution, our new distribution sounds familiar, looks familiar to the normal distribution. Right, it is convergent, it's becoming more convergent, and we have more lesser values, lesser spreading. That is, obviously, if you put median, the frequency of the median would increase the most. We can see the frequency of median suddenly spiked up by a lot, and it becomes a bit thinner, and it becomes more similar to the normal distribution. That's what we are seeing. Right, we can see that standard deviation of this is 14 and standard deviation of this is 13. That is, the standard deviation changes and it becomes less because we have more values nearer to the median. That makes obviously more sense. We had none values, and those none values are now changed to median. Hence, the standard deviation of the age median column should obviously be lesser than this one, and we can see the practical proof of it. Now, coming to the disadvantages and advantages. First, advantage is easier to implement, really easy. We had to create only one function. Now, second advantage is faster way to obtain the complete data set. It makes complete sense, at least in theory, that if not anything, at least replace it by the median. Right, it is something better than nothing. And disadvantages is it distorts the original variance. As you can clearly see, it distorted the original variance and its standard deviation, and our distribution changes a bit. Right, this is one disadvantage, because sometimes what we need to do is we need to capture the distribution of the data in some of the cases, but we lose the distribution of the data if you do a median imputation. Right, and it impacts the correlation. Just 1 second, I'll have some water. Right, so what we say is it impacts the correlation. Now, to understand this better, let us say there was another column which had a strong correlation with the age column. Right, it would like, let us say the price of the ticket is related to the age, because if you're less than 18, it would be a different thing. If you're more than 18, it would be a different price. Right, now the actual correlation gets impacted because, like, the missing value could have been anything. it could have been less than 10, it could have been greater than 30, it could have been greater than 60. But now since I've put the median, we get some unnecessary correlations. Let us say the price of the ticket was 100 rupees for less than 18, and it's 200 for greater than 30, and it's 150 for less in that range, 18 to 30. Now the ticket price, like this is the relation. Now let us say there's a missing value at a ticket price of 100. So logically we have to have an age that is less than 18. But if I put the median and the median turns out to be 35, 100 now corresponds to 35. So the correlation got disturbed, right? It impacts the correlation. So that's what we're going to learn here. So just imputing by mean and median impacts the correlation by a lot, and this is the greatest drawback of this method, right? Now coming to the next method, creating a new column feature or assigning a new category completely. Let us see how this works. This is a pretty simple method. Like let us say kbin. What we do is df.kbin null. That is, we create a new column which says if the kbin thing was null or not. And once we see the output, what this indicates is that 77% of the values are missing. That is pretty clear. If I see the df.head now, what we see is there's a new column created, that is kbin null. Just 1 second. I'll stop recording the meeting now because it's running out of 1 second. Right. I think we can have some more recording. We have that much. We can accommodate it. Right. Moving ahead, we will just continue with where we had stopped. So what we did is we created a new column called cabin null, which indicates 1 if it's missing, and it indicates 0 if it's not missing, if it's present. Now checking the mean of cabin null, which would represent the percentage of values that's missing in the cabin column, we get that 77%. Now if I see the new data frame, we clearly see that we have a new thing that is called as cabin null, and it will be 1 where the cabin is missing. Simple common sense, right? Moving ahead. Now what we do is this, you would have learned about group by, right? What we do is we check the conditional probability that given that it is survived, how many of the values are missing. In the survived category, if the person has not survived, 87% of the values are missing, and if the person has survived, 60% values are the missing. So what we understand, the percentage of missing values are more for those people who have not survived than for people who have survived. We gain some more information about it. Now another method is like kbin.fill, like we randomly fill m, right? This is just a string where replacing it by a string, and this the output would look like this. Like obviously we replaced it by m instead of C85. This was a string type. Kbin was a string type. So instead of nan, I just put an m, right? Now the pros of this method, like this method actually adds literally not a lot of value, right? So we'll understand what we just created a new column that represent if it's null or not, right? Pros is less possibilities with one extra category, resulting in low variance after one hot encoding. Since it's categorical, like this makes common sense, obviously. Moving to the next thing, list item negates the loss of data by adding a unique category. Obviously, list items would negate the loss. That is, instead of simply losing the data, we created a unique category that would store more information and give us more idea about the data. Cons: adds another feature while encoding and which may result in poor performance. Unnecessarily, we've added another column, which actually makes not a lot of sense, and it doesn't draw a lot of correlation. So simply adding another column which adds no value was a bad move, right? So these are the cons. Now the best method would be predicting the missing values. Can we use some mathematics? Can we use some logic to predict the missing values, right? Now the first thing that would come when we think of prediction is linear regression, logistic regression, all of these classic methods. Now we'll try to replace the missing values Like let us say the cabin was missing, right? Now we'll try to replace the cabin by linear regression. That is, we'll obviously change categorical into numerical values, and it'll automatically perform linear regression. And using the given data, given present data, we try to draw some correlation. Like, is there a relation between the passenger ID or the passenger class and the cabin? Is there a relationship between survived and cabin? Is there a relationship between age and cabin? That, you know, this particular age people were given only cabin X, this particular age group was given cabin Y. Or fair, let us say for ticket 8,000 the best cabin was given, for ticket 7,000 the least cabin was given. It tries to form all of these relations, and it will automatically fill it according to those relations, right? Now we have created something called as df with null. That is, it represents only those rows which have null values, only those columns which have some null values, right? And we'll drop all of those rows with null values, and we'll create it called df dot without null, df without null, right? We'll reset the index because we have to reset, because you understand, right? Like, once you have dropped, it may be like 0, 2, 4. So we'll reset it to 0, 1 so that it becomes continuous. So now your df without null would look like this. Now this represents only those values which have not even a single null value in them, and these are the columns. This matrix has completely no null values. Now we use this matrix for the training of our model. Obviously, we can't train our model on missing values, obviously. So we'll use this data frame for training. As you can see, we'll fit the model on the train and test. Like, we'll train dfx and train dfy. We created the linear regression models. Now what we'll do, we'll fill the df with null with this. Like, let us say we use forward fill, and we'll fill it with this thing. We'll see what the change, how the changes would look. We'll see this. What we see is, in the age we have 177 missing values. Now in the age we have 177 missing values. Now what we'll do is, we'll predict using the test data frame, and we'll fill it. Now I've predicted the age, right? Let the age has 177 missing values. I've predicted using the linear regression, as you can see. Now I'll see what is the list of age predicted, right? The age predicted shows this, like age is 184, 832. Just a second. 1 second. Some mismatch occurred. Right. So this we get the age predicted. It's looking a bit random because, you know, 830 is being represented. There's a little error, I feel, in the given data itself, or there's some mathematical mismatch that has occurred. No issues. But you understand the method, right? At least, like, we can use linear regression to fill the missing values. We'll use only the present values to get a mapping between the target variable. Like, say I have to impute the age column. The age column has 177 missing values. So what I try to do is, I'll find the relation of age with all the other remaining columns using linear regression, and then I will start filling the missing values by using linear regression. I'll use linear regression over the, like, let us say age is missing in one of them. What I'll do, I'll use all the other values like passenger ID, passenger class, survived, SIB, SP, parch, fare to fill age, right? And we get the age predicted. As you can see, the age now looks like this: 22, 38, 26, 35. Here we have 369, which is a bit weird, but you get the method at least, right? The pros: imputing the missing value may result in an improvement, obviously, right? What happens, the cons is, sometimes it may perform poorly because linear, like any model for what happens, let us say if we have very few non-missing values that are there, so the training may become really difficult and the model may perform really bad, right? And the next thing is, if there are outliers, the model suddenly tries to find relations that are non-existent, and this may lead to a huge problem, because now the model thinks that it has found a relation, and that relation actually doesn't exist. So it starts filling wrong values. Like, we can clearly see over here, the model thought 369 would be a correct age, whereas age can obviously not cross 100 logically, right? At least in this time. So, like, this is a classic example where the model performed wrong. It tried to find some relation that doesn't exist itself, and hence it has filled a value that practically isn't possible. Whereas in this case, it's filled a possible value that is possible, at least. 26 was possible, but in this case it's filled a bad value. So these are the cons. This is the consequence of the using a linear regression or any other model, right? Next method is we can use KNN, like it is inbuilt, and like instead of using linear regression, you use KNN, logistic regression, any of the other method that you know, SVM, KNN, all of those things, and you fill the missing values, just like how you did with linear regression. You do it with other methods, right? So this ends the first slide. We will move on to the next slide, but only after answering all of your questions. And I'll share this with you. Obviously, you can go to all of the references. You can watch these videos, get some better idea. And if you have any doubts, you can PM me or Vaibhav for that matter, right? Now let's have a discussion. If you people want to ask any doubts, anything regarding this. You've understood everything regarding, like, even if you're not clear, do not be bazzled if you're not understood everything. It's like the first time it can be intimidating, no issues, but at least you should get an idea of what is occurring, if not the complete thing. Like, why are we using a linear regression, and if we are using, how did it actually occur, right? Any doubts? In the chat you can raise your hands. If you have no doubts, you can give a thumbs up so that at least I can proceed. Right. Right. So again, I'm not seeing a lot of any doubts, and I'm seeing a few thumbs ups. So I'll proceed. Now moving to the next thing. That is, I just spoke about a thing called outliers, right? In the previous slide, while in the ending phase, I said the outliers may harm the model. Now we'll clearly understand what outliers are, right? So don't worry, this will be comparatively smaller than the previous slide, really smaller, like it wouldn't even take 1/5 of the time. So it would take only 20 more minutes. So stay patient, understand everything is really important. Outliers and missing values would almost determine any data science context you are giving, right? How you deal with missing values decides 50%, and how you deal with outliers, it decides 20%, and your model decision, which model you use, will decide 30%, right? Even given a good competition, this would be the things you should be doing, and that would pretty much assure that you will perform really well in the contest, right? Or any of the tests or whatever it is. What they try to see is, how do you deal with missing values mainly, what is the logic, how do you remove the outliers, how do you deal with the outliers, and next, what model you'll be choosing for your performance, right? So coming to the second most important part when we're dealing with data science is dealing with outliers and scaling, right? What are outliers? As the name suggests, let us say there's a line and there are some 10 points that exactly fit the line, and there is one point that is extremely out of line, like extremely out. That would be called an outlier with respect to the data set. Majority of the data points obey a relation, and one of the point or few of the points do not obey the relation, and they differ by the relation by orders of magnitude, right? They are called outliers. What they do, the thing that they do is, let us say I want to find the relation, right? Now, if I remove those outliers, clearly I can say that I can fit a line. But since those outliers are present, it will confuse my model. Now the model will not be able to fit the right line, because it thinks, okay, since this is so outside, it's this thing is there must be some relation. Whereas it's actually, even sometimes they put outliers in the data set just to confuse you, right? So we have to be careful as to dealing with those outliers, because they'll like harm the model extremely. Like you can't imagine how much of harm can be caused to the model and prediction if you have a noisy outlier, right? Moving ahead, first thing, in statistics, an outlier is an observation that is far distant from the other observations, right? Moving ahead, in a data set, sometimes there are some data which are very much different from the other columns of the data. They are called outliers. Outliers affect the prediction of the model as shown in the behavior, as it shows different behavior from the other data. The outliers can be a result of mistake due to data collection, or it can just be an indication of variance in your data, right? For example, in this data, except player 3, everyone has a 350 plus score. Like you can clearly see, all of them have a 350 plus clear score, and this guy has only a score 10. This guy is a clear outlier in the data set, right? You understand what an outlier is. So any doubts as to understanding what an outlier is, because it's really, really important, right? Right. Assuming no doubts of understanding what an outlier is, we'll move ahead of detecting outliers, right? this becomes very important. One is called as a box plot, right? So you have to have a bit of an idea of statistics for this, really simple statistics. So you'd obviously know what a median is. Everybody would know what a median is, and everybody would know what a standard deviation is. So now what I'll do, given a data set, I'll arrange them in an increasing order, ascending order. The middle value would be obviously called as a median. What I'll do is the middle value, the third 3/4 value, that is the middle of the second half and the middle of the first half. These are of utmost importance for me, right? The middle of the first half of the data set is called as Q1. The middle of the second half of the data set is called as Q3, and the middle of the whole data set is called as Q2. Any doubts in this? You understood the whole point, right? The middle of the whole data set is called Q2. The middle of the second half is called Q3. The middle of the first half is called Q1. Now this Q1, Q2, Q3 decide everything in most of the statistical methods. What we do is we calculate something called as an IQR. IQR is Q3 minus Q1, right? You understood what Q1, Q2, Q3 is. IQR is Q3 minus Q1. Now, what I will do is I will arrange all of the data sets. I'll arrange all of the data points. What I will say, if my value is less than Q1 minus 1.5 into IQR, if my value is less than Q1 minus 1.5 into IQR, I will call it as an outlier. If my value is greater than Q3 plus 1.5 into IQR, I will call it as an outlier, right? Simple definition. I calculated Q1, Q2, Q3. I calculated IQR, that is equal to Q3 minus Q1. Now I'll go through each and every point in my data set, and I will say, if this point's value is less than Q1 minus 1.5 IQR, I'll call it as an outlier. Or if this point's value is greater than Q3 plus 1.5 IQR, I'll call it as an outlier. Now, just a distribution, a normal distribution would look something like this. Anything left of this line is an outlier. Anything right of this line is an outlier. We can clearly see that almost 98% to 99% of the data lies in this range. Only a 1% of the data set would be an outlier. And this is a very, a very pure case, very simple case. Most of the times there will be a greater percentage of them can be an outlier. Simply, you've understood what we are doing, right? This is called as the IQR method, right? Box plot method or the IQR method. Moving ahead, I'll simply plot it and I'll show it to you how this would look like. Right. So like we have taken a preloaded data set in scikit-learn. We have an already loaded data set that's called as load Boston. X is Boston.data, Y is Boston.target, columns equals feature name. Like pretty much simple, nothing great in this, right? What we try to see is we'll try to get the box plot of this data set of the column DIS. You can see the column DIS over here. I want to get the box plot of this DIS, right? Now, seeing this box plot, what do you need to understand? This middle line here indicates Q2. The left line over here indicates Q1. Like this is a box, right? The right of the box, the right length of the box represents Q3. The middle line represents Q2. The left line represents Q1. This represents 1.5 plus Q3. This represents Q1 minus 1.5. So anything to the left of this is an outlier. Anything to the right of this is an outlier. We can clearly see that in this, these 3 points are outliers, right? Is my screen clear? Are you able to understand what I'm trying to say? A thumbs up would do the job. Okay, if you have any doubts, raise your hands. Right. You're able to understand. Okay, I can see a thumbs up coming. Right. So anything to the right of this extreme line is an outlier. Anything to the left of this line is an outlier. We can clearly see that there is no outlier in this range, but we have 3 outliers in this range. So we figured out the outliers by using simple statistic methods. This is method 1, right? Simply by using a mathematical formula of calculating, outliers using standard deviation and median. Moving to the next method, scatter plot. What is a scatter plot? It is just an X versus Y simple plot, right? Now, if I see this scatter plot, you can obviously see that this is a huge outlier. Like this may not be such a big outlier than this point, and this point are extreme outliers that are completely affecting my model. Most of the data lies in this range, right? All these are normal values that will help me predict, but these values, this one, and this one will harm me, right? It will harm me. So it's better that I remove them before creating a model. So the point with scatter plot is, once the scatter plot is plotted, you can clearly see what is the, like I will say, this is my outlier, right? I will say delete all those values which have x greater than 25 but y less than 200. Simple, this value gets deleted. Delete all values which have x greater than 25 and y greater than 700. This value gets deleted. A simple mathematical relation would simply do the job and will delete most of the outliers. This is method 2. That is using a scatter plot to see and understand. A scatter plot is a type of mathematical diagram using Cartesian coordinates to display the relation between various variables, right? This is the most simple method. It's just visual representation. And once you have the visual representation, it is up to you. You can delete one outlier, you can delete 1,000 outliers. In this case, the most logical option would be deleting this one and this one. And this one may be kept, but if you want to be very sure, you can delete these 3 points. This one, and this one, right? Moving to the next method, that is called as a Z-score. What is a Z-score or the Z-score? The Z-score is a signed number of standard value deviation by which the value of the observation or the data point is above the mean value. Simple mathematics, take your value, subtract mean divided by the standard deviation, right? You get this Z-score. Let us calculate and I'll show it to you. We get a Z-score for each of the variables, 0.419, 0.417, 0.417, 0.416. You can clearly see that Z-scores lies between 0 and 1. Okay, it's not necessary, but then in this case, most of them are coming, right? Now coming to this, I'll simply say if my Z-score is greater than 3, just remove it, right? Or first I'll say I'll print it. We have these many values where the Z-score is greater than 3. Once we get the Z-score, you can decide your own threshold. You say the Z, like let us say, what does this represent? How far is it from the mean, right? Like let us say I say a very high Z value would mean that it is extremely far away from your mean. So just remove it. A very low Z-score, that is in the extreme negatives, may indicate that is very far away from the mean. Delete that also. A simple value, simple common sense thing. High, like extreme boundaries of Z-scores would be deleted. As simple as that. And it is up to you, according to the data set, according to the situation, you can delete your, you can set the threshold. The next method is the IQR score. We have already decided this. I just spoke about this. Calculate Q1, Q2, Q3. First, any outlier would be anyone that is less than Q1 minus 1.5 into IQR. Outlier would be anything that is greater than Q3 plus 1.5 QR. Remove all of those values and you get your answer. As simple as that. We calculate Q1 minus 1.5 QR. We calculate Q3 plus 1.5 QR. I'll simply say delete all of them where it is either less than this or it is either greater than Q3 plus 1.5. As simple as that. There's not a lot of rocket science involved in this, right? Removing outliers, we can simply calculate the Z-scores and say if the Z-score is greater than 10 or the Z-score is greater than some value, simply delete them. As simple as that. We simply do the same thing for IQR, nothing great. So calculating and removing outliers was a comparatively simple task. We have only 3 great methods: IQR, Z-score, and scatter plot. For scatter plot, just plot the scatter plot, see by your own eyes. You see what is looking different, what is looking strange, what is looking fishy. Remove those data points. For IQR score, it is just a mathematical formula. Write it down, you will remove. For the Z-score, it is simple, again, simply a statistical formula. Write it down, remove. Nothing great, nothing extreme rocket science or extreme brain application. Simple. Now coming to scaling. What is scaling, right? This is also really important when you're dealing with extremely weird data, where one column represents values in millions and the other column represents values in 0.1. Scaling becomes really important, because if you do not scale, what happens if one column represents values in millions and the other represents values in decimals, 0.1, 0.2? The model starts understanding that, falsely start understanding that the column that has values in millions is more important than that column which has columns in 0.1, which may not be the case always. Hence, delete and standardizing them. that is making all of them lie in a single range would help me understand the model better, right? Now, what is feature scaling? In simple terms, it defines the transformation of features from one vector space to another vector space, right? This would be the best picture for feature scaling. Like, this picture would explain everything if you understand. The values were so scattered, so large, I simply put them into a box and I maintain their significance, right? Now, the relative position of this point and this point doesn't change. It would still remain there only. The relation between them would still remain there. The correlation would remain. Only the point is they become smaller. They're confined in a smaller space, right? The advantage of doing this is when we are using a model for prediction, feature scaled models would perform really, really well. Why? Why is it necessary to perform, the removal of outliers? Sorry, why is it necessary to perform feature scaling? Is it extremely helps in suppressing the effect of outliers. And like in this case, let me say, in this case, an outlier existing over here, once I feature scale it, it would also come within the scope. So the effect or the damage that outlier could have done is now scaled by magnitude, by orders of magnitude, right? It will reduce the effect or the damage of the outliers, right? It fastens the process of optimization because, like, let us say we are bringing down values from millions to within 0 to 1. Hence, optimization and faster running would also occur, or no, like that's common sense. Now, what are the different types of scaling? One is a standard scaling. That is, this would be your formula. Like, what we would do is we would replace x by the z score. We will replace the x by z score. We'll simply subtract the mean divided by the standard deviation, and your scaled value or your new value is this, right? As simple as that. Nothing great. Other one is the min max scalar. What will we do? We'll replace x by x minus minimum of the whole column divided by maximum minus minimum of the whole column. Nothing great in this. So the row, we have one is standard scalar, min max scalar, and the third one is a robust scalar. This becomes a bit, a better way of dealing with things. We'll subtract q1 and we'll divide it by q3 minus q1. Q3 and q1 are the same thing that I've explained before. So this is called as robust scaling, right? Net, the impact of scaling would look like this, right? And this would represent nothing. This is just we were trying to see how things would occur. Right, there's nothing much in the data splitting side. So we were dealing with feature scaling, and this is how scaling would look like, right? Right, this was a pretty small topic, scaling. Right, now moving on to the questions. Any questions on outliers and their detections? Has everybody understood what outliers represent? Why are we detecting them? Why are we removing them? How are we removing them? What are the methods? What are the formulae? What is the logic behind doing everything? Is that clear? Any doubts? If no doubts on this topic, give me a thumbs up and I'll move to the scaling doubts. Right, I'll assume there are no doubts. Moving to the next thing. Any doubts on scaling? Why are we performing scaling? No doubts. Right. Right. We can end the meet over here if everything's clear. I'll share the materials. If you have any doubts, you can message me or Vaibhav. Right. No issues. Any doubt on any of the topics and any doubts, you can either message me or Vaibhav or Vishal. Right. Right. Any other thing that anybody has to say? Any suggestions as to how the workshop went? Like, was there difficulty in understanding? Was it intimidating? Did you feel the explanation level was less? Should we make it more detailed? Anything of that sort? Right. I think everybody slept off. You can leave the meet. Yeah.